Let's take a look at the child of constraint. It's pretty easy to set up. I'll select my target, then the owner, shift select C, and then choose child of. So what this one does is it's going to make our owner bone a child of our target, but through constraints rather than actual parenting. Just to prove that, I can move it around and scale it and rotate it, etc. And our owner bone is going to follow along exactly like a child. Now you might be thinking, what's the point of this constraint if we can already use parenting for that? However, with parenting, you can't slide and turn it off. You can't turn off some axes, for example. So that's where the advantage of this constraint comes in. But the child of constraint is not all sunshines and rainbows. There is a dark side to this constraint, and it's called the inverse matrix. What is that, you ask? That is the information that holds it in this spot here. The child of constraint is the only constraint that uses this invisible matrix to keep the bone in its position. And this can cause problems, especially in animation. So I wouldn't recommend using the child of constraint in a character rig, but if you're using a prop or something that needs to follow along with another target, then the child of constraint is your best bet. I'll show you some of the problems it causes in animation in a moment, but let me try and explain this inverse matrix a little bit more. Just going to jump to a different view. First, I want to show you what the clear inverse button does. I'm going to click this button and you'll see, rather than the bone being 1 unit up in the local Y space and then 1 unit across in the local X space, it's basically wiped out that inverse matrix and it's technically turned it from local space into world space. You can see it's 1 along the Y and then 1 along the X. So without that inverse matrix information, it's just going to use world space, and that's not what we want in this case. We can think about this set inverse button as the reset button, and it's going to recalculate the inverse matrix back to the rest position of our owner. Now for that example, we did just reset it back to where it was at the start. So let me just rotate this target bone and do it again to make it more obvious. So I'll just set the inverse. You notice it has jumped back, and now it's going to say, this offset or this inverse matrix is going to be my new default position. And if I return the target back to normal, you'll see that the bone is now offset. Now, let me show you one of the problems this causes when we try and copy and paste this pose. You didn't notice, but all along I had a hidden child. Plot twist. This is a normal child-parent relationship. I'm just going to rotate our bone. And then I'm going to jump over into my animation tab. That is the Copy Global Transform add-on, which ships with Blender. If I copy this child bone and then try and paste it to the owner, it's miscalculating because of this secret invisible inverse matrix going on. But I will return it back to normal, and then we'll do the same thing in its default position. So let's go copy that pose and then we'll paste it. Boom. And that's why it's not going to be very useful in a character rig. You're going to get some unwanted behaviors with this hidden inverse matrix. And there's one more thing that can go wrong with this constraint, and that is double transformations. When I set this up, you notice that this owner is not actually a child of the target. However, if we do set it up, I'll just go into edit mode and then make it a child. So you can see our relationship line there. Now, when I move our target, we will get double transformations happening. Whoa, what's going on? The first lot of transformations it's getting is directly from the parenting, and then it's getting those same transformations from our constraint, which is why everything is happening twice, double transforms. But that's the child of constraint. It is super useful, but you need to watch out for that hidden matrix.